Hello, and welcome to another installment of Creedon's Maths and Physics. Today we're going to be learning about circle theorems, so let's get started. So the first theorem states that for any arc, like the arc we have along here, that the angle at the center, the angle that it makes with the center of the circle, so our angle that we can mark here is going to be 2 times as big as the angle it makes with the other edge of the circle. So our first angle here is going to be 2 times as big as the angle out here. Now that's what it will look like if they give you an easy version of this question, but they can also mix it up a bit and they can give you a slightly harder version, which I'll show you now. So here we have another circle and we can draw another arc along it. We'll join this arc to the center also. But they can also try and make it a little bit harder by, instead of joining it to somewhere directly above, they can join it to a different random point on the circle. So for example, they could join it to this point here. So again, these ones join to the center, these ones join at a point along the edge of the circle. So based on this theorem, we can again say that the angle it makes with the center of the circle is going to be 2 times as big as the angle it makes with the edge of the circle. If you want to pause the video here, you can take down notes on that into your handout. And this is Theorem 19, by the way. So now we move on to the first corollary to Theorem 19. So again, we're going to look at an arc here, which we'll just highlight in blue. And the first corollary just says that if you join these 2 points to any point along the edge of the circle, the angle they make is going to be equal. So we can measure them out to here and out to here. This angle is going to be the same as this angle. And you can do that for any point along the edge of the circle. So again, this one here will be the same amount of degrees, whatever that is. Again, if you'd like to pause the video here and make some notes into your handout, this would be the perfect time to do it. And just press play when you're ready to resume. So now we move on to the next corollary to Theorem 19. And this one deals with a semicircle. And now there's no functionality on my app to draw a semicircle, so I'm going to do my best attempt at drawing a semicircle freehand. Now this corollary just states that any angle in a semicircle is a right angle. So if we join the 2 ends of the semicircle to any point, say here, then this angle here will be 90 degrees. Similarly, we can do it for any other point. Let's join it to here. This angle here also should be 90 degrees. So you can pause the video now and make a quick note of that in your handout and press play whenever you're ready to resume. Now we're on to the next corollary to Theorem 19. This one again kind of deals with semicircles. So it says that if we have any 2 rays drawn from a point out here and they make an angle of 90 degrees, then the place that they join to must be a diameter, so that this is the diameter of the circle here. So the way it's phrased in the book is that a angle standing on the chord AB, if this makes an angle of 90 degrees here, then our chord AB must be a diameter, which in this case it does look like. Now we're on to our final corollary to Theorem 19, which says that if we have a cyclic quadrilateral, which is a 4-sided shape that's drawn inside a circle, and it can look like anything, it doesn't have to be a square, then opposite sides must add to 180, or opposite angles must add to 180. So this angle plus this angle, let's call them A and B. We can say the measure of angle A added with the measure of angle B gives us 180 degrees. And we can similarly say that for the other 2 angles. Let's call them C and D. The measure of angle C plus the measure of angle D should give us 180 degrees. Again, you can pause the video here to take down notes into your handout, which I'd like to see tomorrow. So now we're on to Theorem 20, and Theorem 20 just states that for any tangent, which is a line that touches the circle at one point only, like for example this line here, which touches the circle at this point, this tangent, we can call it T, is perpendicular to a line that runs from the tangent to the center. So here's our line from the tangent to the center of the circle, and we're just saying that this tangent is perpendicular to our line that runs from the center. And you can pause here and resume when you've got your notes taken down into your handout. So now we're on to the converse to Theorem 20. So in the converse to Theorem 20, we have a point P which lies on a circle. And we have a line L which goes through our point P. There's our line L. So if this line is perpendicular to the radius out to P, if it's perpendicular, then L is a tangent to our circle. So again, with this being a converse, it's the opposite of Theorem 20. So this is proving that this is a tangent, whereas regular Theorem 20 is giving us the information that it's a tangent, and then we're figuring out from that that this is 90 degrees. Here we're given that this angle is 90 degrees, and we're figuring out from that that this line L is a tangent. Again, pause the video here so you can figure out what you're going to write down into your notes for this. I suggest writing down something that looks similar to this. If O is perpendicular to L, then L must be a tangent to our circle. Okay, now we're on to the corollary to Theorem 20. And this states that if two circles, like the big one and the small one here, share a common tangent, so this line is a tangent to both of them, then their centers and the point of the tangent are all along the same line, or collinear. So if we join up those 3 points, the center of each circle and the tangent point, again, they should all be collinear or along the same line. So you can pause the video here to take a note or a diagram into your worksheet, and just press play when you're ready to resume. So now we're on to Theorem 21, and this theorem gives us a circle with a center O and a chord AB. We've also got our line here coming out from O, which is perpendicular to the chord AB. Now, Theorem 21 says that if we draw our line from O perpendicular to the chord, then it will bisect that chord or split it up into 2 equal parts. That's one half of Theorem 21. So you can take a note on this now. If we draw a line perpendicular to the chord from the center, then it will bisect our chord AB. The second half of Theorem 21 states that if we have a chord AB and we draw a line perpendicular to it, or 90 degrees to it, which cuts it in half, then its perpendicular bisector, this line here, must pass through the center. So if you'd like to pause the video here and take down a diagram to help with your understanding of Theorem 21, I would like to see all of that worksheet filled in fully for our next class. If you have any questions, you know to send me a message. Thank you for watching.